So what if I told you there's a way to clean up one of the dirtiest oil extraction processes on the planet? And what if the secret ingredient was nuclear power? Today, we're diving into a pretty incredible technology that aims to do just that, create a zero-emission barrel of oil. But as you'll see, solving one massive climate problem might just be creating a huge shockwave in a totally different global market.
All right, let's get into it. First up, we'll unpack the big problem with heavy oil. Then we'll look at the, frankly, elegant nuclear solution that's been proposed. We're going to break down exactly how the tech works, explore the massive environmental payoff, and then finally, this is where it gets really interesting. We'll uncover the huge, unintended consequence for the global uranium market. Okay, so to really get why this new technology is such a potential game changer, we first have to understand the very dirty, very expensive problem it was designed to solve.
This is the big one. This is the central engineering challenge of places like Canada's oil sands. The oil there, called bitumen, isn't like the crude oil you might be picturing. It doesn't flow. It's this super thick, semi-solid stuff, kind of like tar, and it's stuck in the sand hundreds of meters underground. So how in the world do you get it out?
Well, for years, the answer has been a process called steam-assisted gravity drainage, or SAGD for short. And honestly, the name pretty much says it all. You use steam to heat up the oil, then gravity helps it drain down so you can collect it. You're basically building a gigantic kettle on the surface, burning massive amounts of natural gas to boil water into steam, and then you pump that steam deep into the ground. The steam melts the bitumen, and then you can pump it out. The problem? You're burning a ton of natural gas to do it, which means a huge carbon footprint.
And that carbon footprint isn't just bad for the environment, it's getting really, really expensive. With Canada's carbon tax set to hit 170 Canadian dollars per tonne by 2030, the old way of doing things, burning gas for steam, is just becoming economically unsustainable. The industry desperately needs a new way to bring the heat. Okay, so that's the problem. Now let's talk about the innovation. This is where a really powerful idea comes into play, using the clean, immense heat from nuclear energy in a completely new way. We're talking about a total paradigm shift for nuclear power here. For decades, we thought of nuclear as doing one thing, spinning a turbine to make electricity, to generate electrons. But this is different. This is about using a small modular reactor as, well, basically a giant clean kettle. It produces an incredible amount of heat to make steam for big industrial jobs, like oil extraction, all without a single puff of emissions.
So this is the crucial point. Think about it. Traditional SAGD is a package deal. To get the steam you need, you have to create CO2. You can't get one without the other. Nuclear SAGD completely decouples that relationship. It separates the energy you need from the act of producing carbon. It's a total game changer.
Okay, now for the fun part. Let's get our hands dirty, look under the hood, and see how this whole system actually works.
Before we look at the full diagram, it really helps to think about it in three main stages. First, you've got the reactor making the heat. Second, that heat goes to work deep underground. And third, everything that comes up gets processed and recycled right there on the surface.
And here it is, the whole shebang in one image. It might look a little complicated, but it's really just those three steps we talked about. Over on the left, that's your small modular reactor, your clean kettle, generating intense heat to make steam that's between 300 and 540 degrees Celsius. Then, in the middle, that steam gets injected into the top well underground, which creates this big steam chamber that melts the bitumen, letting it drip down into the lower well. And finally, on the right, the mix of oil and water gets pumped to the surface, they're separated, and get this, 85 to 95% of that water is cleaned and recycled right back into the system to be used again.
So we know how it works, but what's the real payoff? What does this actually achieve for the environment and our climate goals?
The numbers here are just staggering. A single 600-megawatt facility using this nuclear process avoids over 3 million tons of CO2 emissions every single year. That's compared to a site burning natural gas. I mean, that is a massive, massive climate win.
And look, this isn't some pie-in-the-sky idea. It's grounded in real intellectual property, like U.S. Patent 8186430B2. And this patent provides the blueprint for what the industry is calling a zero Scope 1 barrel of oil. So what's that mean? Well, Scope 1 just means the direct emissions that happen right there at the extraction site. So this is basically the recipe for getting oil out of the ground with no direct carbon footprint from the process itself.
And why this matters goes way beyond just oil. This kind of clean, high-temperature heat can decarbonize all sorts of heavy industries. For example, you can make what's called pink hydrogen, which is just a cool name for hydrogen made with nuclear power, super efficiently.
It gives countries a powerful new tool to hit their climate targets, and it helps break their reliance on volatile natural gas markets.
But, and you knew there was a but coming, right? Here's the twist. It turns out that when you solve one huge problem like oil sands emissions, you can accidentally create a massive new pressure point somewhere else entirely in the global energy system. And this is where it gets really fascinating. Check out this data from the World Nuclear Association. It's forecasting that global uranium demand is going to jump by 28% by 2030. And that's not just for new power plants for the grid. A huge chunk of that new demand is being driven by these new industrial applications, just like the one we're talking about. So what happens when demand skyrockets like that? Well, you get a serious problem. The market is staring down the barrel of an annual supply deficit of around 60 million pounds of uranium by 2030. Put simply, we are not on track to be digging enough of it out of the ground to meet all this new demand.
And this table really lays out the perfect storm that's brewing. On the supply side, major high-grade mines are starting to run out, and it could take more than 15 years to get a new mine up and running. But at the exact same time, you've got this explosion of new demand coming online, not just for industrial heat, but also for powering the absolutely massive electricity needs of AI and data centers.
And all of that leads us to this crucial takeaway. This new demand from industry and AI is what some are starting to call shadow demand. And that's a perfect term for it, because it's this huge structural shift that the current uranium price doesn't seem to reflect yet. The market is still kind of thinking about nuclear in the old way, just for the electricity grid. It hasn't fully grasped that this new industrial and AI demand isn't optional, it's on 24/7, creating a completely new, rock-solid source of demand.
So it all leaves us with this final, really critical question. We are in this massive global push to electrify everything and decarbonize our world to fight climate change, which is incredible. But as we create these amazing innovations, we have to ask ourselves, what other hidden pressures, what other new resource demands are we underestimating along the way?